With normal vision, we can see over a wide spectrum of distances, near and far. If you're nearsighted, this means that you can see things that are only close up to you, and far things can't be resolved. In this case, we say that the farthest an object can be viewed clearly from you is defined as the far point. Normal vision doesn't have a far point. You can theoretically see infinitely far if the light can actually reach you. To correct for nearsightedness, where the far point is less than infinity, we need to use a diverging lens. This lens will use the real object to create a new image at your far point so that you can view it. Again, we rely on the lens equation to characterize our vision. In this case, because we care about the eyeglass lens and not our cornea, our image distance is going to take into account the distance between the image at our far point and the distance between the lens and our eye. Notice here that it's going to create a virtual image because it's only one lens and it's upright compared to the object. So here we can get the distance, but make sure that you plug in a negative value. Now the object distance will just depend on how far away the object is. So if it's at an infinitely far distance, we would say infinity. But anytime we have a different DO, we can plug that right in and figure out what F is. Now, figuring out the focal length of your glasses is what the doctor's supposed to do, and this is usually reported as a power. So this power is measured in reciprocal meters or diopters. So for nearsightedness, you typically have negative diopters available. So I personally have nearsightedness, so my prescription is a negative 5.25 diopter prescription, which means that I have negative 5.25 as my reciprocal meters, and I could find my focal length and therefore work backwards to figure out my far point.